So we're now going to move into the Year 12 textbook, and the first exercise is just a review of what we learned in the previous chapter in the Year 11 textbook. So let's just run through that quickly. We looked at circle calculations. We said, okay, if we have a sphere that's a 3D object, and a great circle is a circle that has a radius which runs in the center. Now, a sphere can be any ball-shaped object, and obviously that's going to relate to the Earth. But we'll just review this one. We have a radius of 50, and it's asking you what is the circumference of this circle when the radius is 50. So we remember that it's 2 pi r for the circumference of a circle. So it's just 2 times 50 times pi, and that should give us a length of 314 centimeters. We've then looked at great circles. We've said that the equator is the only great circle of latitude, but the meridians are all great circles. And the meridians are those that run through the North Pole or the South Pole, and they make up the largest circles. The latitude lines are parallel to each other, and they're all small circles except for the equator. We remember when we read different places on the surface of the Earth, we read lat then long. So I am going to see what line that is on, and it's 20 degrees. So if I'm looking at G, 20 degrees north, because it's north of the equator, then I read the up and down lines, which are longitude, lat then long, and that's 20 degrees west. If I were to pick another one at random, C, here we go. I'm looking below the equator. 10, let's just draw that so it's easy to see. 10, 20, 30, 30 degrees south, and then I'm reading east-west. So it's going to be 10, 20, 30, 40, 50 degrees, and that's east. So that's reading latitude and longitude. We've noted that the Greenwich meridian, or the prime meridian, runs through London. Anything east of the Greenwich meridian is in front of London, and that's this side of this sphere, and anything on this side here is west. There are 180 degrees of east. There are 180 degrees of west, and that's quite helpful because you add them up together and it's 360 degrees, and so that's a whole circle. We've looked at places like Singapore and said, okay, how do we locate our Singapore? We read latitude, then we read longitude. So we've also noted that they're on a great circle, so any line of longitude or the equator, there are 111.2 degrees per kilometre. So if I've travelled 10 degrees along this line of longitude, I have just travelled 10 times 111.2 kilometres. If I'm travelling across a small circle, then we need to think about the cosine multiplied by the cosine degree of latitude in this equation. So if I've travelled from here to here, for example, and that's 40 degrees east, and that's 60 degrees east, I've travelled 20 degrees, and let's imagine this is a latitude of 60 degrees south. I'm just saying I've travelled 20 degrees multiplied by 111.2, multiplied by the cosine angle of latitude, and plug that into the calculator to get the answer. We've looked at distances along the surface of the Earth. So, for example, I'm traveling 40 degrees north to 50 degrees north. I've traveled about 10 degrees along a great circle. And so that's just 10 degrees times 111.2 to be 1,112 kilometers. If I wanted to calculate somewhere like the distance from Brisbane to Perth, I would think, here's Brisbane, here's Perth. How far have I traveled? That's about 40 degrees, and it's along this angle of latitude, cosine 30 degrees, multiplied by 111.2 kilometers, and that's 3852 kilometers approximately, because they're a little bit above and that's a little bit below the angle of the latitude. We previously looked at these two worked examples as well, looking at the distance from one part on the line of longitude to another part on a line of longitude, noting that this is a great circle. So if I'm traveling here on this surface of the Earth, traveling down, I'm traveling from 42 up to 50. So I've traveled 8 degrees up this line of longitude, which is 12 degrees west. I've traveled a total of 8 degrees. Now that's just 8 times 111.2 for a total of 889.6 kilometers. If I'm looking at crossing the equator, I just need to recall that I have to add these together. So here I am on 12 degrees west again. So traveling from 42 degrees north down to the equator, and then another further 50 degrees. I've traveled a total of 92 degrees. So when I cross the equator, I add these two together. If I am on the same side of the equator, I'm just going to minus them. So work out your angular distance and multiply it by this 111.2 kilometers per degree. In this case, we've traveled 92 degrees, and we need to multiply that then by 111.2 for a total of 10,230.4 kilometers. When we consider small circles, just be careful to note where we are. So that means that these two will be the same generally if they're a small circle, and it'll be either above or below the equator. So you just need to picture which line you're traveling along. So we're traveling 42 degrees north, so that's a fair way north of the equator. And we're traveling 120 degrees west, 120 degrees west, and we're traveling to about 70 degrees west. So we've traveled a total of 50 degrees. So you just minus them because they're on the same side of the Greenwich meridian. Now, because we're traveling across a small circle, it's going to be the angular distance multiplied by 111.2 multiplied by the cosine angle of latitude. In this case, it's 42 degrees. And that will give us an answer of 4,131 kilometers. When we cross the Greenwich meridian, we will be adding together, and just make sure that when you add them together, the angular distance is going to be less than 180, otherwise you just go the other direction around the Earth. So likewise again, it's the angular distance, in this case it was 170 degrees, multiplied by 111.2 kilometers per degree multiplied by the cosine of the angle of latitude that you're traveling. Now your work is page 253 and that's exercise 5A.